Okay, it is now 6:31 actually. Let's get started. I hope everyone can hear me and can now see me. Hi, everybody. So we had a poll up here tonight asking about the calendar competition. I'm glad to see those 3 people said yes. Looks like a lot of undecided. If it's undecided, it can be very simple things you want to do artwork, and even for the, lots of undecided now. So yeah, if you want to do super simple things, that's fine. Some people submitted already and this did a drawing and a quick bio of it. So love to see a lot of you guys participate in this. Okay, can everybody hear me? Okay, good. I'm going to close this poll, but again, if you can participate, it'd be awesome. If you have any questions or need some suggestions, let me know. They are due on Sunday, and it should be a fun cross-curricular activity to do. Okay, so let's get started with some announcements. Welcome to the webinar. I really appreciate all of you coming tonight. I know you're all very busy people, so very glad that you're here. And tonight's plan is we have our career speaker, Matt, here. And then our teacher presenters are Sara, Carlos, Julia, and Lauren. And then we have Erin, Ranjana, and Anne. So a quick overview of what we're doing tonight. And so we're going to do a couple of announcements. Matt's going to be on, then teachers, and a quick wrap up. So the announcements, I've already mentioned this, but our calendar art competition entries are due by September 30th. I put a link at the top of the chat window so you can see more information about that. And yeah, I hope to see a lot of entries from you guys. Then the next part, Adobe Connect, I wanted to remind you that all of you, hey Louise, welcome. I wanted to remind all of you that you can use Adobe Connect for appointments. If you'd like to ever use it, just let me know. You can talk to other classes that way, or feel free to use it to talk to other teachers as well. Then we have our discussion board and blogs. We have a discussion question up right now. And always feel free to go do blog entries and comment in other blogs. Next up, our demographic survey. The link to that is also in the web links. And I think we have about 25 participants so far, responses to that so far. And it should take you less than 2 minutes to do that. It's a really quick survey, a lot of basic questions. This is a required element from NSF, so please help us out by doing this. And I learned this week you can also do it on a phone, or you can do it on a iPad. So easy ways to do it there also. Okay, Carol. It is choppy for you guys. Make sure all your other programs are shut or enclosed. That can sometimes affect the quality of the volume. We also have our SCRC investigations. And in September, we have the GGIC, which is the Great Global Investigation in Climate. And we have our phenology and climate part. And then in October, we have our climate and land cover IOP, and also our phenology and climate. So if you are doing green down data, it's a great time to go out and do it. It's really pretty easy and quick to do. We've been doing this at the Globe Program Office, and it's been really fun to go out and check our tree. We're doing it twice a week and checking and see how our leaves are changing. In total, it takes maybe 10 to 15 minutes to do it each time. And again, it's pretty easy to do. How to do it is explained on the SCRC Phenology and Climate webpage. And if you have questions about it, you can definitely email me. Okay. So just to tell you before we get out today, our next webinar, October 10th, we have a career speaker, Matt Coleman. Our teacher presenters are Sara and Michelle. Yes, and Steve. His kids are doing green down. And like he said, it's very easy and fast. Thank you, Steve. And then our calendar competition again. Okay, so let's go ahead and switch over to Matt Fenzel to present to us about his career. Okay, Matt, you are on. Okay. Do you have questions about the phenology IOP while we're waiting? That's awesome, Jen. Yeah, we've noticed our tree isn't changing very quickly here, but other trees are changing. We have a box elder, and it's taking its time turning yellow. I bet when we check it next time, it'll have some more yellowing to it. There he is. Okay, Matt, you're back on again.
Okay, can you hear me?
We can hear you, but it's a little bit echoey.
A little echoey? Okay.
Yes.
How about this? Better?
Try
Better?
Still a little echoey.
Okay. I'm going to try to switch to my microphone really quick.
Okay.
Can you hear me? Or see me? Okay.
Cannot see you. Make sure you share.
Okay.
Okay. So you can be heard pretty well by other people.
Okay. I guess, is it still a little echoey on your end?
It is, but if everybody else can hear you okay, that's fine.
Okay.
Oh, it is
Okay.
echoey.
Hold on. And then did my video camera cut out as well?
It never showed, yeah. Make sure you put
Okay.
start sharing.
Okay. Can you hear me now? Okay.
Much
Sorry,
better.
I'm going to have to talk like this, which you'll see in just a second. Yeah. Okay.
Okay. And we can see you.
Okay. Is it? Okay. Can you guys actually see me? Am I moving or did it stop?
It froze, but it'll stop again. It'll come back.
All right. Yeah. Thanks, Julie. Appreciate you having me on here. I guess should I just get started? Okay. Yeah, first off, yeah, thank you very, very much for having me. I've been fortunate enough to work with teachers over the last few years with being involved with the Global Alumni Organization, and I have the utmost respect for you all. I love what you guys are doing, and yeah, please keep up the good work, and if there's anything that we can do from a global alumni point of view, please let me know. My contact information at the end. So yeah, thank you very much for taking the time out of your old busy schedule, and hopefully I can share a few things that are, relatively insightful from a career standpoint of you. So I'm Matt from Louisville, Kentucky. I'm a global alumni for the North American region. Um, and as a graduate of the GLOBE program who is willing to volunteer their time to contribute to the success and sustainability of GLOBE, and that's just something that we are, that I do on a volunteer basis. So, can everyone still hear me and see me? No? Quieter? It's still frozen. Okay. Again. Yeah, for whatever reason, my webcam is kind of cutting in and out for whatever reason. Yeah, for whatever reason, my webcam is freezing up on me every time. One more time. Still? All right, sounds good. All right. So, anyways, sorry about that. Gotta love technology, as Tammy said. I'm glad I put these slides up, and I apologize in advance. I thought for initially that I was going to be presenting amongst children, so I tried to and kids, so I tried to keep it relatively simple and with a few other random points about me and what I've been doing. So, anyways, I'm 27 years old. As I said, I live in Louisville, Kentucky. My current occupation is a sound is not good anymore. Can you hear me now, Rhonda? No? Yes? Barely? Okay. I'll try to speak very, very closely to this. Okay, so I currently work as an international sales manager for a Phoenix process equipment company, which is an equipment manufacturer. I'll get more to that later. Um, Globe School, I was a student at St. Francis of Assisi High School, graduating in 1999. And from there, I went to high school at DuPont Manual Magnet High School in Louisville, Kentucky. And then from there, I went to James Madison University, graduating in 2007, and majored in integrated science and technology, which is an applied science degree with a triple concentration in environment, energy, instrumentation, and measurement. Um, randomly, some sports that I like to play: soccer, tennis. I played a little bit of rugby in college. Hobbies are skiing, fly fishing, hiking, photography, music. Current reading Song of Fire and Ice. And then it's some music I've been listening to. Um, the last movie I was able to watch in theaters were the Hunger Games, and randomly, this is a random fact. I once ate a dozen Krispy Kreme donuts in one sitting, which was not was probably kept me from ever eating Krispy Kreme donuts again. So, anyways, kind of getting into more about my progression into my career into what I'm doing now. 1980s, as I was a kid, I pretty much spent as much time as possible outside, building forts, getting dirty, pretty much standard kid stuff. And I'd always had an attachment, I think, to the environment and to science. And at my elementary school, I began to participate in science fairs, and my first experiment was an ice melting experiment. And then from that point on, I did a lot of science fair experiments involving water quality testing and analysis. And within that time frame, I also was introduced to Globe at St. Francis of Assisi, and I think this is where I really started to develop an interest in science and technology. And for whatever reason, I've always been interested in water, and as you'll see, as I've progressed, I seem to always go. I always seem to go towards water as an interest in what I do. So in the 2000s, I was in high school, but I still stayed involved with Globe, even though my high school was not a Globe um, school. I still tried to help out with events and mentoring students and anything that I could. And then from that point on, I went and studied applied sciences at James Madison University, and also linked up with a teacher who was trying to incorporate Globe into their teacher curriculum. So yeah, go Dukes. All right, Jessica, nice. Um, yeah, so from it was just it seemed natural for me to go towards this science and technology, and it's something that I always had a passion about. But I really fundamentally think that it started with Globe and the protocols that I was able to be introduced to at such a young age, and just the inquiry-based learning that came out of that. I also had, as a thesis, I had decided to design and build a water extraction or water pump and irrigation system for a village in Kenya, and actually had received some EPA funding to implement that shortly after graduating. So that was really, really exciting to do as a recent college graduate. Oh, sorry, I'm probably, can you hear me now? I'll be better. Okay. Sorry, my microphone started to drift away from me. So in 2007, graduated JMU and became a process engineer for Phoenix Process Equipment Company. And in the 2010s, I've continued as a process engineer and then have eventually transitioned into international sales, which I'll get to shortly. So here's just a few photos of basically most of my collegiate career and early on the top left of me just going through a science fair competition and evaluating some student science fair projects. And down below is some of the design work and installation work for the irrigation system that we installed in so moving on specifically to, hopefully it'll keep moving. Okay, so currently what I'm doing now, I work for Phoenix Process Equipment Company, as I mentioned, and we are leaders in liquid solid separation and residual dewatering technologies. So basically we try to separate liquid from solid and dispose of it in a meaningful way. So essentially a filtration system, and we do this in a lot of different markets, from mining to municipal to wastewater treatment to industrial processes. And just to guys, I looked this up on Wikipedia today because the process engineer is a pretty broad term and sometimes difficult to, I guess, understand exactly what it is. But this Wikipedia definition did a pretty good job of describing that. And as you can see below, I did everything from laboratory analysis to technical reporting, process field evaluations, system design, mass balances, CAD, flowsheet development, programming, and then somehow ended up into a international sales manager position where I've been doing a lot of sales work for our company, developing the export markets, which mainly are in Australia, India, Russia, and South Africa. So let's see, and at the very bottom, I've still been involved with Globe and the Globe alumni, and I can't tell you or emphasize enough how much Globe means and how much you guys mean to me and everything that you guys have been doing. So thank you again. Here's just a few examples. My company has provided some pretty interesting opportunities, from designing full-scale systems. Here's a flow sheet design of that, as well as going to do commissioning startups all around the world. The one on the top left was in Algeria. That's me. I got covered in a bunch of, I don't know what it was. I think that may have been coal. I got really dirty that day. And then as well as some installations with some automation design and controls. And yeah, so let's see. I think that's about it. I kind of wanted to leave it open for questions. Hopefully there's still time. Sorry you guys couldn't see me and there were some technical difficulties, and hopefully it wasn't too boring. And please feel free to email me at any time if you have any questions, or if there's anything that the alumni can do. I would be more than happy to try to get you in touch with somebody in your area, or or I can help. It doesn't matter. We love to get involved and help out wherever we can. So really sorry for that little alumni plug, but hopefully that made some sense, and you guys were able to take something away from that. Marcy, I would say within the U.S. there's probably 40 alumni that I know of. I mean, obviously there's thousands, or there's there should be thousands at this point, but there's 40 that I know who have expressed interest, and then there's probably 10 to 15 who I know are active and definitely willing. But the thing is, it's difficult to balance work with volunteering, so it's difficult for some and easier for others. It just depends. So, let's see if I can get this website. Yeah, any other questions?
Matt, that was great. Thank you. And Matt, so was I wanted Matt to come because he was a global alumni, so to talk about his globe experiences. And
What's that?
I wanted just
Oh.
you to come to talk about your globe experiences as well as
Yeah, I can't emphasize enough how I think influential Globe was in my career path, and just the way that it's evolved over time. It's I think I just look back on my days of doing some of the water protocols, and we were able to go out every Friday afternoon to a stream and do flows and macroinvertebrate studies, and it was excellent. I can't emphasize enough, and I still enjoy getting involved with it when I can. So it's great. So yeah, please. I mean, you guys are an inspiration to me for sure, and all that you guys do, because I know this is difficult to incorporate into your lesson plans, and you have to put in a lot of extra work, and it definitely means a lot, and it goes a long way. So thank you.
Okay, so let's get the Florida teachers on here now. Again, Matt, thank you. We appreciate you coming tonight.
All right, thank you very much, Julia. Hopefully I did all right, and sorry for the technical difficulties.
They happen. It's okay. Thanks. Okay, Carlos, I'm putting you on. Hey, Carlos, you guys are up.
Hello. Sound coming through okay?
Hi. Sound great.
All right, so good evening, everybody. And we have a lot of teachers here, actually. We're all here in Sarasota, Florida. What I'll do is I'm going to move out of the screen for a second and just kind of let you introduce yourselves here. So I'm Carlos Hernandez again.
Lauren Watson.
Eric Bailey.
Julia Calderon. Sarah Kuhar.
Miles Degati.
And this is the science department here at Sarasota School of Arts and Sciences. So tonight we're just going to go through and kind of let you know what we've been up to so far. So without further ado, here we go. All right, just to give you a reminder of where we are located in Florida, we're just south of the Tampa Bay area, about 45 minutes south of that in the Gulf of Mexico. The picture you see in the top right-hand corner is of our downtown area, which is we're relatively close to it. They see your baby bump.
Oh.
So, the picture you see in the backgrounds are our beautiful Ringling Bridge. And then on the bottom right-hand side is actually our brand new building. We've been in here less than a year, and there was a lot of construction going on. In fact, on the next slide here, I can kind of show you. Well, this is where we're at located, so you can see the beautiful Sarasota Bay there as well. On the left-hand side, you can see downtown Sarasota, and then we're just outside of the downtown area. It's really nice here. The only problem is that we don't have a lot of greenery. We do have some trees. In our campus, there's a lot of dirt and a lot of sand because of all the construction. But I'll show you here on the next one so you can see what I'm talking about. Okay, so we have two aerial pictures of our campus being built. The one on the left-hand side shows the school building we're in right now, and then above it is the framework for the gym. And then on the other side is just kind of inverted, so you can see the framework for the gym on the bottom and then the building on the top. What the arrow is pointing to is where we had our weather station last year. We're trying to figure out where to put it, and we're going to talk about that in a little bit. But I know that Sarah was mentioning something she wanted to say about the
weather station.
yeah, the weather station and the wind and everything.
Yeah, like what we don't want is the location. Well, we need a location where all of the kids can access on their own without much supervision, which limits us to like our parking lot and the surrounding areas. But we don't want like a wind tunnel effect from being in between the two buildings, which is like the location where we had last year. So we're waiting. We have to give our principal a list of a couple of different options, and we're waiting on approval for that.
Okay.
Yes, we're part of the mosquito group.
Yeah, we're the mosquito people. One of the things that I wanted you to notice too is that, again, if you look at the surrounding area of the pictures there, you can see that there's a little bit of grass, but mostly what we have around here is a lot of sand. Okay. All right, so move on to the next one here. This is one of the activities we have done so far, where we have bell work when the students come into the classroom, and what we did is we projected this on the screen, and we have some pictures of mosquitoes, and we asked students to write down as many questions as they could, kind of reacting to the pictures of the mosquitoes here. Very similar to what we learned at the Globe class that we went to over the summer. Oh, yeah, the L2R2, yeah, that's right. One of the things that we found that was interesting is that when doing research, it's only pregnant female mosquitoes that actually bite humans, which I thought was interesting. I thought it was all kind of mosquitoes. But anyway, the kids came up with some really good questions. And then this is what else we've been up to. So far, students have brainstormed potential research questions related to mosquitoes and climate. We've made contact with our Florida Assistant State Climatologist. Her name is Melissa Griffin. We also had Lori Tarleton from the Sarasota County Mosquito Management Service. She came and spoke to our students about mosquitoes. And what happened is the students actually viewed pictures, well, some diagrams, but then they also had mosquitoes under the microscopes as well, and some of the different species that we have here in Sarasota. Students have read articles on climate change and mosquitoes to kind of practice doing a little bit of research and citing sources. We're also in the middle of working on our science fair projects at school, so this actually ties it in perfectly to the scientific method and everything we've been doing so far. We have been in contact with our partner school in Connecticut and plan to make compare some of the different climate and land cover information between our two schools, and we'll be doing that in the future. All right, so here's some of the slides here from Lori when she came in from the mosquito management. There's actually scientists that are working on kind of developing a model to predict when the mosquito disease, the risk of mosquito disease will actually be around. So they're using a combination of rainfall data, the water table, and actually bird populations as well. So you can see on the picture there's some high-risk areas. Luckily for us here in Sarasota, we're not in the high-risk areas. Well, not yet anyway. And it kind of depends on whether there is a lot of rain. We can have a lot of mosquitoes, but also if it's dry, we can actually have a lot of diseases being spread as well. And the reason for that is that birds, we have found out that can be carriers of a lot of the diseases. So when we have a lot of rain and we have a lot of opportunity for mosquitoes to breed, then of course the mosquitoes will transfer the disease. But when it's dry, a lot of the birds will actually come together, and there's actually a higher risk of them transmitting from bird to bird. All right, so here's some of the pictures, and actually you can see Lori doing her presentation with that very slide here for our students. And then on the top right and bottom right, you see some of our students actually looking at the different mosquitoes through the microscopes in the classroom. On this one too, on the left-hand side, these were like samples of mosquitoes and stuff, right?
Yes, they're the ones they're looking at in the case. There are still in the larval stage. They're prepared specimens, and the ones under the stereoscopes, there are adult mosquitoes.
Okay. And then we also have, I know you wanted to talk about this one here real quick.
Oh yeah, this one, I guess the mosquitoes find their prey by detecting CO2 emissions. So there are mosquitoes in various stages in this container that the student's holding. And they were very calm. These two containers were over in the corner. And when the kids had a chance to go over and examine them, pick them up and have a look at them, the mosquitoes began to detect their breath, the student's breath, and the mosquitoes just went wild inside that container. You could hear them buzzing, really trying to get out. Really cool thing to see. And you can see on the student's face there her kind of amazement at how much they're moving around.
Oh, Carlos, that's
Oh, yeah.
also that's like the same kind of container that we're ordering when we're going to be starting to collect our own mosquito larva data as well.
And the students are able to identify or see the difference between the types of mosquitoes by their little siphon. So they actually could see, which species we're looking at specifically by looking at those samples.
Mm-hmm. Let's see what else we got. All right, so of course we talked to our students and the fact that mosquitoes need stagnant water to develop. This was kind of interesting, that second bullet you see on there, that it only takes 1 tablespoon of water to produce 100 or more mosquitoes. So then one of the things that we looked at is our floor tiles here on the school campus. They're a foot by a foot. And the kids were trying to calculate how many mosquitoes can hatch out of that amount of water. So that was kind of gross, but kind of interesting too. Of course, temperature and food will determine how quickly the mosquitoes are going to develop. And only certain species of mosquitoes are the ones who actually transmit diseases too. So they're starting to look at the differences between those as well. All right, so here's some other pictures in the classroom where we're doing the bellwork assignment, again trying to come up with different questions. And then on the right-hand side, on the top and bottom, we started walking around our campus to kind of get ideas for our land cover and the green up and green down that we're going to be doing. And then here is the field that is the greenest around us right now, because again, there's a lot of sand. So the following is going to be a couple different pictures that the students have taken just to kind of get used to their surroundings. So I just wanted to show you some of the different things that we have around here. On the left-hand side, we have a palmetto tree, and then on that tree itself, there's actually 2 species hanging on it. There is a cactus hanging on there, and there's also a vine hanging on there. So this was kind of a nice way to start introducing competition between species. On the top right-hand side, you can see where the nobody's really trimming these trees, so you can see the dead leaves are still there. Some of the different oaks and everything we have on the bottom. The left-hand side, we have one of our conifers here, covered in Spanish moss, which of course is neither Spanish nor moss. We have a lot of epiphytes here, which are the air plants that hang out in the trees. And the Spanish moss, actually, one of the closest relatives to them would be something like a pineapple. So over on the right-hand side, I forget the name of this tree here, Lauren. What's this one here?
What's this philodendron?
No, this one here.
Schiflera.
Schiflera.
Mm-hmm.
And the cool thing about this one is that they're just starting to bloom, and they have these really cool red blooms on the top. So that'll be something that the kids can actually take pictures of and document. This is some of the land cover on the right-hand side. We do have a couple of flowers right now. And again, just another close-up of the conifer with some of the Spanish moss hanging from it. Some more Spanish moss. And then over on the right-hand side is this philodendron. Again, it's just kind of wrapping around. And that's actually a dead tree that is wrapping around. So again, they're trying to find as much sunlight as possible. This is a shot from the field looking at our campus. So again, it's just right down the street. It's not even a block away. So the good news is we won't have to take a bus or anything to do any kind of field trip or anything. We can just walk down there during class time to collect our data. I know Lauren wanted to talk about this one here.
That's it, Moat Marine, and we take our 6th graders there. That is a Mangrove Estuary, and so we have a lab program study that the children do there, including, depending on the weather, if it's nice, they get in and they get nice and wet. But it's great for them to see the 2 different types of mangroves, and also then they will sample the leaves for the salt that it actually transpires and salt on one side. So that's some of our children doing a lab out at Moat Marine.
Okay. So here's what's next. We have to kind of determine sampling locations for mosquito larvae with the help from Lori, our mosquito management lady. We're going to be setting up our weather station. And again, we're just kind of waiting for approval from our administration for the location. One of the things they're going to be doing is, in the picture that we showed earlier of our parking lot, they're actually going to be putting plants and everything in there. So they're doing a little bit of landscaping. So we kind of have to wait until they finish that before we can go in and put in our weather station. So hopefully in the next month or so we can put that in there. Of course, begin collecting data. And we're going to try to Skype with our partner school. And again, just kind of compare some climate and land cover between our two sites. And that's it. Do we have it? Oh, wait, go ahead.
Well, a few people were saying, like, commenting on how much we have done. You should know that we are pretty much consumed by science fair already for like the first couple of months of school. And so we've used this as a way of teaching them, you know, how to ask questions, how to ask better questions, how to research those questions. And then when we get into even like analyzing data, we want to have data from this as well, even if it's historical data. So I mean, it really hasn't impacted. I wouldn't say it's really taken up any extra time so far, and we haven't started the data part, but we've really just integrated it with what we already do.
Okay. So if you have any questions, we'll just kind of read through here and see what you got.
Thank you, guys.
Bye.
Okay.
We are a charter school, so we're a, what would you say?
School.
Oh. Okay, what's off? I'm sorry about that. Can you type it in the chat window? Okay, Anne, Erin, and Ranjana. Okay. You can see Ranjana. Now we can see Erin.
Oh, it figures that mine's not going to work again. It says it's on. Can you hear me? Okay, then I'll just go ahead and get started and just know that I'm waving at you guys. Erin, one back from this. This is the second slide. Okay. I haven't been able to get a lot of work done yet this school year. This is the location of my school. As I told you all during the summer, it's located right on Bayou St. John. And this is where we'll be doing our water testing. In the backyard behind this building is where we'll be doing our atmosphere testing. So school started and our very first topic was lab safety. And then as soon as we got to the end of lab safety, then Isaac hit. And we were out of school for one whole week. Erin, one more. We were out of school for 1 week, but when we got back, it opened up a lively discussion about climate, atmosphere, what's going on with the weather, and things like that. In addition to having the students out, and most of them didn't have power, so they weren't able to keep up with assignments, it also delayed the equipment that was supposed to be coming in, and all of the equipment was somewhere in some warehouse and finally has been delivered. So as soon as we got back from the storm and our spontaneous week off, and yes, we do have to make up most of our time that we lost, then I had the students do their pre-test, and they were interested in finding out what they were going to be doing this for. I had mentioned the program to them, but I didn't want them to know anything about it before they did the pretest. So we have our pretest completed. And then I brought them out into the backyard of the school. And in the backyard is where we'll be doing our atmosphere testing as soon as I get the station set up. And in the backyard, we did a project called the Sense of Place activity. It's something that I've done every year to get the students interested in looking at the environment, even though it is, well, you'll see that in a minute. It's just a concrete environment, but we have one little grassy patch, and that's where I have them doing their sense of place activity. So they went outside and they had to map it out, and on their map they had to include all of the different living things that they could find, and it bordered on concrete paths. So it's the only grassy spot we have right in the middle of the backyard, and they were able to map that out and notice all of the different types of land cover. We have one little tree there and several different kinds of grasses, but not too much else. Then we were able to determine our GPS coordinates, our altitude, and our muck classification, which is all concrete, as I said before. We're right in the middle of a residential area. We're the only school in that area and all houses all around us. And as soon as we determined that, I introduced them to the atmosphere, and we did an activity where they had to calculate the percent of oxygen in our air. And this activity uses a rust activity where they remove water, they remove oxygen from the air and do a water displacement. So we had this set up for a couple of days where the steel wool was rusting and using up the oxygen, and then the water moved up the test tube. And it actually comes out to be pretty accurate. It's pretty close to 20% oxygen, which amazed them. They thought the air was all oxygen. And then, as soon as they calculated that, we did an activity where they had to graph.
And I'm out in Fairfield, Montana with things that
and see how we have oxygen.
Second grade through 7th grade, I have 7 students this year.
Before.
This is the students after we came up with kind of our initiative.
And since we did this graph activity,
climate
we have done a lab on the Coriolis effect so that they can
see, I forget how I have that worded up at the top, the quality,
the weather
and then we just had a
and
list we would do,
of course, the
macro invertebrate
rotating turntable so that they could see the
hurricane
patterns. And next week I should have my weather station set up, and
I had students, since we don't have a lot of climate data, do research interviews. I had them interview local farmers and everybody who lived in the area more. And it was interesting to see the similarities between the students, because every student that in your had 2 stories that they told everyone about. One was when the weather changed 60 degrees over a period of 24 hours, and another story of when it was super hot during one of the summers. So it was interesting to see that similarity, and all of the students were commenting about what they noticed there. And we went out, we haven't happy to do a lot so far. We don't have a weather station set up yet. We're also in the process of trying to get that going. And then about 30 miles from the school, and did mapping of our testing environment. So this is our stream rate that we were testing in, and the students are out there mapping. And we took out the GPS and found which direction was north and south and east and west and so on. And that was kind of interesting for students to understand that maps are not always with the north. And then here we are doing testing and some for our discard water here, and it says poison on there, so I don't have to worry about any of the kiddos drinking it. And then some of the ladies here with the safety gear with their glasses and their masks and their goggles and everything. I was lucky enough to have a volunteer come out that had actually done some water testing in college. Such groups, so I made sure that everyone had an opportunity to do at least 2 tests. And then the next time we go out and we'll so that the kids have an opportunity to do different and have some of the chemicals in it that are a little bit more worrisome. I'm just having my 7th grade girls do that. Younger students when just they wanted to play in the water, so they were challenged and also watching the minnows. And then one of my kids found a snail, decided to try to identify the charts. And then on the lower left-hand side, one of my 3rd graders popping one of the tabs into the test tube. Again, they're reading, watching minnows there. And we went through kind of some ways that we could improve the testing process for right now. And one of the ones is they kind of wanted to speed up the process because my little kids tend to get a little bit more impatient. So the more parent volunteers so it could go a little quicker. And real for studying the macroinvertebrates, they thought like some candy and spoons because they weren't having a lot of turkey-based teachers, that we were more time at the testing location. And then I will hand it over to Ranjana for her part here.
Can you hear me now? Hello? Can you hear me now? Okay. Okay. We are working for the importance of water quality for human consumption. Like I said in the beginning, we were testing 3 different samples, but now this year I started testing the water only from the River Jacinto. And this river is channeling Houston. It is in the outskirts of Houston and quite far from our school. So I went there to collect the sample for students, and we did the basic testing for the water. Move on, Erin, please. Next slide. This is where we are located, right in the heart of Houston. And students are testing the water, the basic tools they are using. And when I started doing this, I didn't get the equipments uh, then, but now I have it and I'm ready to install them and started using them. When we just started with the basic testing. Erin, please move on. Students, their test water. Information about the River Jacinto from where I collected the water samples. Move on, please. Since we have just started testing, even though we are in school for past 1 month, several reasons we could not move too much. So these are our questions: how a river naturally evolves and forms its path. What are the imperfections of the river water? What causes these imperfections? Is the river water safe and drinkable for humans?
And
If you had any questions,
Please move on, Erin.
okay,
Does climate
go
affect
ahead,
the
Julie.
surrounding vegetation? Is there any change in water quality in past 10 years? What is the role of climate for change in water quality? So gradually we are moving to our base topic, the climate, and I hope by December we'll be able to accomplish all this.